Hello folks, so in this video we're going to talk about how we can create the equation of an exponential function if we have 2 points on its graph. And the way we're going to do this to make it hopefully make the most sense is to compare it to doing the same process with a linear function. So let's find the find the equation of the graph through these 2 points. So we'll use say 2, 3 and oops, that's not very pretty, and 5, 24. So on the left side here, we're going to pretend that the graph is linear, and then alongside that, we're going to pretend the graph is exponential and see how the process varies, but it shouldn't vary too much. Let me move this over actually a little bit. Okay, so let's remind ourselves what a linear function looks like, what the equation of a linear equation will look like. So if I'm using our kind of not standard, our most typical form, we would have slope-intercept form, y equals mx plus b. For an exponential function, we could almost call it slope-intercept form because it does give you the quote-unquote growth, although we wouldn't call it slope, right? This b here, that would be again the multiplier, and a now again is the y-intercept. Okay, well, our goal is to find a and b here, or in the case of a linear function, m and b. So usually you're going to start off by finding the slope. Let's find the slope. Just like how in the second part, the first thing we're going to do is find the multiplier. Right? And again, these are just two ways of defining growth. It's just for a linear function, that term for growth is the slope because it adds the same amount every time. Whereas for an exponential function, we call it the multiplier because again, you're multiplying by some amount every time. Okay, I'm actually going to do this a little bit different than we have been, but I'm going to show you that it's actually not any different than what we have been doing. And the way I'm going to set this up for the linear function is I'm just going to plug in these 2 points and create 2 equations. So I'll plug in 5 24, and now I'm going to write it like this. Mx, so x is 5 now, plus b, 3 equals m times 2 plus b. So all I did was plug in x and y for these 2 points. Notice we just have a system of equations here, and then our unknowns that we're trying to find are m and b, which is exactly what we're trying to do for this to find the equation of this function. We need to find the slope m and the y-intercept b. And so I could just solve this system. The way I would do that as is so far is I would just subtract them, wouldn't I, to eliminate b. So if I do that, I'm gonna want to subtract these equations. Let's see, I'll get 24 minus 3, which by the way is our delta y, right? Equals, let's see, 5m minus 2 would be 3m. Again, this 21 right here, that's our delta y. This 3 is our delta x. And so if I, solve this by dividing both sides by 3, m is going to equal 7. Again, that would be 21 over 3, which is again delta y over delta x. Kind of neat. Okay, well, let's just finish up the linear case, and then just to kind of wrap it up, we'll find the y-intercept by again plugging in our slope into either of those equations. It doesn't matter which one. So I'll plug into the bottom one because the numbers are smaller. So I'll get 7 times 2 plus b. If I solve this, then b is going to equal negative 11. And therefore our equation, our linear equation through these 2 points, is just y equals 7x minus 11. Okay, an exponential function works pretty much exactly the same, except the process is going to be ever so slightly different just because of the nature of the equation. So let's scooch down here a little bit. Okay, I'm going to start off again by plugging in these 2 points and creating 2 equations. Sorry, I didn't realize my mouse was just floating there. So the 2 points are again 5, 24. So 24 equals a times b to the x, in this case x is 5. The second equation is going to say 3 equals a times b squared. Now we just have a system and that we need to solve. The question is, how do I solve this? Well, one way is I could substitute if I wanted to. I could solve both equations for a and then set them equal to each other. But I could use elimination right away. It's just instead of subtracting or adding the equations, I could divide them. Because as long as I divide both sides by the same number, it's okay to do. So I'm just going to take the left side, divide it by 3, and the right side, divide it by ab squared. We'll see here, the resulting equation is 8 equals, and you see the a's cancel. Let's see, b to the 5th divided by b squared, that's a b, not a 6, is equal to b cubed. And the last part is I just need to take the cube root of both sides to figure out what b is. So I'll take the cube root. And that leaves you with b is equal to 2, our multiplier. Just be careful here. Again, we're so used to saying b is our y-intercept. But in the case of the exponential function, that's actually the multiplier or the growth. It does kind of suck that they use the same letter. Last part again, we're going to want to just find our y-intercept. So I'll do that by plugging that 2 into one of the equations that we started with. So it doesn't matter which one again. I'm going to use the easier one, the smaller one. Smaller meaning has smaller numbers because I don't want my life to be too complicated. Plug this in. Let's see, that would be 4a on the right side. So that would mean that a is equal to 3 over 4. So our equation, when it's all said and done, is y equals 3/4 times 2 to the x power. So hopefully comparing this process to how you would do it with a linear function helped make creating the equation of an exponential function not too crazy.